Thank you. Yeah, thanks a lot for having me. I'm excited today to talk about BigCode. I'm a research lead at Hugging Face, which is also partly an open source company. And I've spent roughly the past 2 years working on this open collaboration called BigCode. But before I go a little bit more into the details of the kind of things we did in BigCode, I want to take a step back and look a little bit at the definition of like what closed and open models are, because it's a little bit different, differently viewed as people view it, for example, in open source software. So on the one hand, on the one extreme, you have the closed models. This is your everyday ChatGPT, Google Gemini, or Claude from Anthropic. You can access those models only via an API. You don't know exactly what's going on behind the scenes. You can't run those models locally. And depending on what the company offers, you can't fine-tune these models. So they come as they are, and you have to use them like that. Then you have kind of a middle layer, which we usually call like open weights models. In these models, like you have access to the weights, so you can download the model, you can fine-tune them, you can kind of do whatever you want with the model weights, but you have no idea what went into the pre-training data. So you don't know whose data is in there, you can't opt out of being used for these training runs. You can't do like a thorough analysis of what kind of biases are in those models based on the data set. And more scientifically, it's really hard to know whether these models were trained on some of the benchmarks we use to measure how good the models are. And we can't reproduce them easily because we don't have access to the data or the training. And these are probably some of the most famous models, like the Llama models from Meta, some Mistral models, French startup, or DeepSeek models, for example, from China. And then on the other extreme, you have like the fully open models. To be fully open, a model needs to release the pre-training data, needs to release the training code, and also the weights. So you can really understand what went into the model and why it behaves as it does. There's a few reasons why people don't do fully open releases these days. For some company, building like cutting-edge LLMs is their competitive edge, and if they release the data sets, for example, which are usually the secret sauce, they give away that edge potentially. There's also a number of lawsuits going on at the moment regarding copyright, so you're a little bit on the safer side if you just don't talk about like what kind of data you use for pre-training, and it gets a little bit harder to prove what's in your data set. And as we probably heard a lot during this conference, if you do open source something, then you have kind of the burden of maintenance. So there's only a handful of models that are truly fully open. There's the Bloom model that's already a couple of years old now, which was an initiative by Hugging Face as well to train an open GPT-3 model. And recently, LNAI released the Olmo family of models and is working on those. So we thought, roughly 2 years ago, it would be really nice if there would be like an open alternative to GitHub Copilot, a fully open alternative, where you really know what kind of data went in there, how those models work, and so the community can build on top of them. And that's why we initiated the BigCode project. It's a collaboration between Hugging Face and ServiceNow. Those are kind of like the compute sponsors, and we're also like putting in a few full-time people to work on this. But in general, BigCode is like a fully open research collaboration. So anybody can join. We have policymakers in the project. We have lawyers thinking about the licenses, as well as engineers and researchers. And the goal is to be fully transparent about the data processing, the training code, and release the models with a permissive license. So how do you start such a project? Like, how do you build a large language model for code? The basic building block, as I mentioned already, is like a good pre-training data set. This is usually the reason why some models perform better or worse, usually you can trace it back to better or worse quality of data. So how do you build a high-quality data set for code? What we did is we went to GitHub Archive, which archives all actions that are happening on GitHub. And we used that database to gather 220 million repository names. And then what we did is, for a few months, we did git clone. So we cloned 220 million GitHub repositories, which yielded roughly 100 terabyte of data, code data, with like 50 billion files, and some repositories have been deleted. So from those 220 million repositories, in the end, we had roughly maybe 140. What we then did is a little bit of additional filtering. So first, we removed some file extensions. For example, usually it doesn't help to train language models on binary data or binaries. And that already brought us from like 100 terabytes of data to 70 terabytes of data. Then we did additional license filtering. We've used only permissive licenses for the first iteration of the data set, which then brought us from like 70 terabytes to roughly 6 terabytes of data. Finally, we did some analysis, tried to figure out, like, now we have that very big code data set. We didn't do any specific filtering, trying to figure out like what makes a really good code data set. And we did multiple things. We tried to look at like how well commented, for example, is a piece of code, or how many GitHub stars did it get. But in the end, we found the only thing that reliably helped improve the performance of the model in the end was doing more deduplication. And so we had an additional step of what's called near deduplication, where we tried to get rid of all the small variants of a file, for example, config files where maybe only a field changes and things like that. And that ends up with a data set of roughly 3 terabytes. Both of those data sets you can see them with a small hugging face emoji, they're available to download, so you can play with them or train your own models. In addition to that, as I said, we wanted to be fully transparent about the data set and the data that went into it, and just having like a 10 terabyte data set on the Hugging Face Hub is not like a convenient way for a user to check whether their data is in our data set. So we built a small app that's called Am I in the Stack? The stack is the name of the data set, and you can go to the website, you can Google Am I in the Stack, you'll find the app, and you can enter your GitHub username, and you'll see all the repositories that were in the different versions of the stack. In addition to that, if you don't want to be part of future iterations of this project, there's an opt-out mechanism where you can just open a GitHub issue with your username, and in the next iteration, we're going to remove all the repositories that you want to opt out of. So we wanted to scale, after the first iteration of the stack, we wanted to scale the data set further, and we found like software heritage, as mentioned in the introduction, is already like a great archive of open source code. And just when we were thinking about the second iteration of the data set, they put out a blog post about like responsible use of their data for language model training. And we found it's very well aligned with the things we already were doing or wanted to do anyway. So the first principle they put out was like any model that's been trained on their code should be redistributed with an open license as well. So they didn't want like companies to use all the code they gathered to build like in-house commercial models. They wanted models to be open. They wanted to full traceability by providing the software heritage identifiers, and also they want an opt-out mechanism in place. So that's really well aligned, and we used the software heritage archive to scale up the stack for the stack v2. And as you can see, we went from roughly 6 terabyte to 60 terabyte of data, and for the deduplicated one, from roughly 3 terabyte to 30 terabytes, so roughly 10 times bigger data set. So we had a bunch of good data sets, and so we started training some models. We started pretty small. This is kind of the iteration cycle of the models we did. So we released the first prototype model, which was supposed to be a small internal run, but since the model was pretty good, we decided to release it around Christmas, called Santa Coder. And you can see it's fairly cheap to train, like maybe $8,000. It can only program in 3 programming languages, and it was trained on 250 billion tokens. For reference, Wikipedia is 6 billion tokens, so we're already like 30 times more, using 30 times more data for that small model than Wikipedia. And it's a fairly small model, it's just 1 billion parameter, which is for modern LLM standard, a tiny model. Then our first big model was StarCoder, which was a 15 billion parameter model trained on 60 programming languages. And then with the Stack V2 that we built with Software Heritage, we trained StarCoder 2, which we trained for 4 trillion tokens. That took several months to train. And it saw programming code of over 600 languages. So it's a pretty diverse model. And at the time when we released it, these are a couple of benchmarks to measure a little bit how well these models perform on various tasks, from code completion to reasoning to math, or how well they can use repository context. StarCoder 2 was the state-of-the-art model. This is already a few months ago, so there are now better models than ours, but it's pretty exciting that with an open community, you can build a state-of-the-art language model in a few months. Another thing that's quite exciting, between StarCoder 1 and StarCoder 2, the 3 billion parameter model of StarCoder 2 was as good as the 15 billion parameter model of StarCoder 1, which means within a year, you get the same performance for a model that's 5 times cheaper. And before I go over time, I want to close with this slide, which is, I think, the most exciting thing about the BigCode project, which is the ecosystem that these open releases enable. So since we released the stack, every code language model that has been trained, also if it wasn't ours, was using the stack. And also a handful of models used our StarCoder model and fine-tuned it for specific things, like a specific, for example, SQL model, which can translate text to SQL. So that's quite exciting that by releasing data sets and models, you enable a lot of other people to do the same thing. Now, maybe I have time for a few questions. And thanks a lot for the attention.